over on 411, add and subtract radicals. And 2 square root 12 minus 3 square root 27 plus 2 square root 48. In order for you to add or subtract these, they have to be like terms, which means the radicals have to be exactly the same. They have to be all square root 3s, all square root 6s, but they cannot be different numbers underneath the radical. It's the same as if you tried to add 3x plus 2y minus 3z. You cannot combine those numbers. You should know that by now. You can't add and subtract those. They're not like terms. You got the same situation here. That's like an x, a y, and a z. If that was all you knew, you would not be able to do anything with this problem. But what you do have to do is simplify each one of those. Those are not in simplest form as radicals. So you would have to do that first. So I'd put the 2 out front, and then I would simplify that square root 12. Is 12 a perfect square? No. So what do we have to do? Not a decimal. What do we have to look for? Not factors. The biggest perfect square that goes into 12 is 4. So it kind of gets tricky here because you can write that in here and then you'll have to drop down and show several steps. So maybe the best thing when you're simplifying those is just to write it maybe right above it. Some of you will be able to do it in your head, and that's fine too. But if not, I'd write it somewhere else instead of, again, where you're trying to simplify. So 4 is the biggest perfect square that goes into 12. And what is the square root of 4? 2. So you end up with 2 square root 3 there. Now that radical is simplified. And if you multiply 2 times 2, square root 3, you would have 4 square root 3. So you do the same with 27. Is 27 a perfect square? So what's the biggest perfect square that goes into 27? 9. So you could change that one to 9 times 3. And what's the square root of 9? So you would end up with 3 square root 3, and multiplying those two, you'd have 9 square root 3. Now, one thing I did notice last time, we hardly used a calculator at all except to simplify bigger radicals in the homework. But when I gave the homework last time, there were kids trying to type in square root x times square root y, and they were trying to type that in their calculator. This is not a calculator section where you're going to be able to do a whole lot of that stuff. It's just simplifying. So keep that in mind. If you type in 3 times square root 3 in your calculator, it's going to give you a decimal. That's not what we're going for here. We want the radical form. And same with square root 48. It's not a perfect square. What's the biggest one that goes in? What? 16, how many times?
3.
So 16 times 3, square root of 16 is 4. So we end up with 4 square root 3 there, which would simplify to be 8 square root 3. So now all our radicals are exactly the same. They are all square root 3's. So we went from 3x, 2y, 3z to now they're all x's. And what would you do there? You just add them together. You'd get 5x minus 3x would be 2x, and that would be your answer. It's the same thing here. You need to look at this square root 3 like it's an object that you can pick up and hold in your hand. So here you have 4 of them. You have 4 square root 3's right there. You're subtracting 9 square root 3's. And then you are adding 8 square root 3's back. So where would you end up? At what? 3 square root 3. Would be your answer for that. Questions on that one? We'll go ahead and keep going forth then. Next is multiplying binomial radicals. 3 square root 5 minus 2 square root 3. That is a binomial. You get 2 terms there, and then 2 plus square root 3. And 2 terms. So that is a four problem. We'll have several of these in your homework. So you take it step at a time. So what you're basically doing in this problem is multiplying up here. In these two problems, you're multiplying these two numbers together. You're going to be doing that when you FOIL, but it's just a step in a bigger problem. That's not all you're going to do is multiply two numbers. You got to multiply a bunch of numbers. So take it step at a time. FOIL, you multiply the two first numbers. 2 times 3 square root 5 would give you 6 square root 5. So what confuses kids, what do I multiply here? Do I take 2 times the 5 and get square root of 10? Do I take the 2 times the 3? How do you know which one you're supposed to do? Right. This number, this 2 is just 2, and this 3 is just 3. There is no radicals involved there. So that's the two things that you'll multiply together. You will just do the 2 times the 3. If you had square root of something there, then you'd multiply that times the square root of 5, but you don't. So it is just 6 square root 5. That's first. Then you do outside, so these two outside terms. So now what do I multiply is the question. What's in front of the square root 3? A 1. So you could look at that as 3 times 1, and they're both positive, so it's going to be plus 3. Square root of 15. You multiply those two numbers. 3 times 5 is square root 15. What if you got square root 16 there? Then you would change that to 4. So simplify the radicals if you can. And then inside these two numbers, that's negative and positive, so you know it's going to be minus. 2 times 2, so that one gives us 4 square root 3. And then last, 2 square root 3 times square root 3. And it's going to be minus because you got negative 2 there. So what's in front of the square root 3? 2. This one. So we got 2. And then the rest of it's square root 3 times square root 3. What happens there? 3. You end up with 3. So some of you, again, can do all that in your head and get 6 right there. If not, just write times 3. So do we have any like terms? We have square root of 5, square root of 15, square root of 3, and then out here we just have 6. No. I'm going to go ahead and change that to 6. So what did we do up here? Try to get back to it. No, here it was. Here we didn't have any of the same radicals, so did we just quit the problem? No, we simplified them. So we need to check that down here. Can we simplify any of those? We have square root of 5. Is that 5 perfect square? What's the biggest perfect square that goes into 5? There isn't one. Same with the 15 and same with the 3. There are no perfect squares that go into those. So that is all you can do to that problem. But do check and make sure there aren't anything. There isn't anything you can simplify. Questions on that, on foiling, how we got any of those numbers? 5 square root 3 minus 6 times 5 square root 3 plus 6. So what do we have to do on a problem like this? We're multiplying binomials. foil. But does anybody notice anything special here? Or remember anything that we've done in the past, or what those two things are called? What? Not that word. What's the only difference between the two? Plus and minus. Nobody remembers?
You don't have to do that.
You don't have to do the first one. Somebody said it's the C word. Conjugates. Excellent. Those are called conjugates. The only difference between them is the sign. So they are called conjugates. And then what were you guys on? What do we have to do or not do?
Like you can only do like first and last.
You can do all, but you only have to do first and last. So we look at this problem, we know it's a FOIL problem. But what you can remember, if they are conjugates, you don't have to do outside and inside. Just a shortcut, which when you do the division problems, comes in very handy if you remember that rule. If you do FOIL, these two terms will cancel. You'll have plus and minus, you'll cross them off. So if you do FOIL, it's not going to cause a problem. It's just going to be more work for you. So that's why I'm trying to get you to see these are conjugates. You only have to do first and last. So in the first, we have 25, right? 5 times 5. What's going to happen when we multiply the square root of 3? And we're going to end up with 3. So it's basically going to be 5 times 5 is 25, and then times 3 would be 75. And then the outside, the last, we don't have to do outside, would be minus 36. Your final answer is 39. We are moving along a little quicker than we did on Friday, so if you got any questions, make sure you stop me before we go on. The last thing is division on page 412. We have 1 minus the square root of 3 on the top, and we have 5 plus square root of 3 on the bottom. Who would like to cross off the square root of 3 and square root of 3 because anything over itself is 1? No one? Well, that's good because you can't do that, but normally there are a lot of kids that see this, and so they want to just cross that off. You've been taught so many thousands of times, anything over itself is 1, you cross those off. You can't do that here because it's being added or subtracted to another number. It's not by itself. You cannot cross those off. You can't do anything with the 1 minus square root of 3. The radical simplified. You can't add them. You can type it in your calculator, get a decimal, but we don't want that. So we can't do anything to this problem. But what is the problem here that we can't leave? There is a radical in the denominator. We have 5 plus square root of 3 down there. So if there was something that we could multiply this 5 plus square root of 3 times, that would end up not having a radical in it. So let's look up here, this previous example. If we had this, we multiplied times the conjugate, what did we end up with? Is there a radical in there? So maybe we could use that knowledge down here. What would we want to multiply by and to ensure that we wouldn't end up with a radical? 5 minus radical, or square root 3 on the top and the bottom, and that's exactly what we do. The goal is simply get rid of that radical on the bottom. And now we know that if we multiply by a conjugate, we will get rid of the radical on the bottom. So that is the method that we use. I would put all 4 of those in parentheses so you know they are binomials and you are foiling them together. Will we have to foil the bottom? No. But we will have to foil the top. So first times first would give us what?
Just be positive.
Just, yeah, positive 5, 1 times 5. Outside, we have 1 times negative square root 3 is what? Negative square root 3, good. And then on the inside, we have 5 times negative square root 3 minus 5 square root 3. And then the last, negative square root 3 times negative square root 3. First, we know it's going to be what? Positive, and the radicals cancel to give you 3. And then on the bottom, we just have to do first and last. What's first? 25 minus 3. So we're getting the hang of that. Radical just cancels, leaves you with 3. Anything we can combine on the top? What?
5 and 3.
5 and 3 is 8. Anything else? Yeah, those are like terms. That's just like minus x minus 5x. So negative 1 square root 3 minus 5 square root 3 would give you negative 6 square root 3. Very good. All over 22. What does that look similar to from your past? When did we get answers that looked like that? What? Somebody said it. What were you saying? Parabola thing. Yeah, what do we call that? Quadratic formula. Absolutely. And that's exactly what we've got here. An answer that looks just like quadratic formula. What's the only difference that we would have? No, that's not the only difference. What did we have with quadratic formula that we don't have with that right there? Plus or minus. That's the only difference. So you'd have exactly the same answer with the quadratic formula, except that'd be plus or minus. So knowing that, then what do you think we can do to this? Is there anything else? What? Take a 2 out of all 3 of those numbers. Make sure you do that. You want it as simplified as possible. So we would end up with what? 4 minus 3 square root 3 all over 11. Remember that rule. Don't forget that was the last step. Questions before homework? Remember, only working on algebra until you're done with it. Working quietly, asking me questions if you've got them. We're doing 10 through 28 and 32. So 10 through 28 and then 32. So we're just going to skip 30 there. And then 38 through 49. These are evens. 38 through 49. That section is all.